Look at these glowing spheres dropping into the dark. This is exactly what happens every time a developer plugs generative AI into their software. Millions of queries are sent straight into an unmonitored void. The moment these applications go live, engineering teams hit a wall. They suddenly have to answer a simple yet nearly impossible question. Is my AI actually working? Ancient Vedantic philosophy has a concept for this called Maya, the illusion of function. On the surface, the chatbot replies and the interface looks smooth, but underneath, token costs are multiplying and hallucination rates are climbing entirely out of sight. Dropping a language model into an app takes minutes. Proving that it behaves reliably in a production environment remains a massive, unsolved blind spot. The tools available to fix this are severely restricted. Platforms like Datadog require enterprise contracts starting at $40,000, while others, like Langsmith, lock you into specific, narrow development frameworks. Traditional software monitors track server pings and uptime. They verify whether a machine is on, but they lack the semantic depth to evaluate how an AI processes language, how it reasons through steps, or how it retrieves facts. Developers are left guessing. They need a framework-agnostic way to measure when their system drifts off course, regardless of which model or provider they use. Engineer Venkat Chavan Nagabhushana built ObserveML to fill this exact gap. By dropping in just 3 lines of middleware code, ObserveML gives an application a functional layer of self-awareness. The architecture relies on the Vedantic principle of Sakshi, the impartial witness that observes everything without interfering. This diagram illustrates how the backend acts as that witness. The primary data stream, the user's interaction with the AI, moves horizontally. The ObserveML middleware duplicates every prompt, completion, and tool call vertically into a high-speed ClickHouse database. The user's experience is never slowed down. By capturing every piece of data instantly and without judgment, the system compiles the complete, unedited record required to evaluate the AI. Once the data is captured, ObserveML applies another principle, Viveka. This is the practice of discerning true signal from distracting noise. Most developer platforms overwhelm you with hundreds of complex charts. ObserveML actively rejects that approach, curating the interface to focus only on what dictates success or failure. As you can see in this dashboard design, the clutter fades away. You are left looking at exactly 3 critical dials: the token cost per session, the highest tier of response latency, and the actual task completion rate. Effective observability is never about hoarding the most telemetry. It is about surfacing the precise data needed to understand the model's behavior in the real world. This brings us to the hardest engineering problem in AI observability, figuring out how to measure a hallucination mathematically. ObserveML tackles this through its intelligence layer, leaning on the concept of neti-neti, meaning not this, not this. The system systematically strips away the model's false confidence to find the factual baseline. To measure prompt drift, the system converts prompts into coordinates on a grid, measuring semantic distance. Zooming out for RAG retrieval, we check the distance between the AI's response and verified fact clusters, proving if the model used relevant data or simply hallucinated. These continuous checks take the abstract, erratic behavior of a neural network and translate it directly into quantifiable, manageable risk. The unmonitored void we started with is now mapped with specific data points. Engineering teams can now review a 7-day cost forecast and set automated alerts for performance anomalies. Instead of reacting to an angry user complaining that the chatbot is speaking gibberish, developers catch the failure in the data before the user even finishes their session. And because ObserveML is framework agnostic, it shatters vendor lock-in. It tracks the behavior seamlessly, whether you route queries to OpenAI, Anthropic, or an open source model running on your own servers. By locking every prompt and completion, the internal logic of the language model becomes visible and measurable. This turns a speculative integration into a tracked, auditable part of the software stack. This brings us to a final guiding principle, Dharma, the idea that infrastructure has a specific duty. It must support the product, but never become the product itself. Venkat Chavan Nagabhushana's approach focuses on accountability. By capturing every trace, he provides the mechanism for humans to audit and verify the model's behavior. Look at how this chaotic swarm of geometry comes to an absolute halt under the lens. As artificial intelligence models grow more complex and alien, our most vital tools won't be the ones that built them. They will simply be the ones that allow us to watch them clearly.